Hello, this is the generally approachable Sudoku for the 27th of March 2024. It is Wherefore Art Thou by Philip Newman, featuring exam clues. So we're seeing a lot of clues from outside the grid today. Well, in these few days, I mean. So let's take a look at the rules. Normal Sudoku rules apply. So place the digits 1 to 9 in every row, every column, and every 3x3 box. Exams. So clues outside the grid tell you the sum of the first x digits in the corresponding row or column, starting with the digit adjacent to the clue and continuing away from the clue, right? So a lot of information to unpack there, but basically what they're saying is that for any clue here, take the look at the digit next to it. Let's say whatever digit that is. Let's say this is a 3. Then take that number of digits from this clue. So if it was a 3, take the first 3 digits and sum them up, and then you should get 8. So this, not like that. This is valid because this number indicates how many digits you see, and the sum of those digits add up to 8. So that's valid. And that is true for every single one of these clues in the directions they're pointing. So yeah, those are all the rules. With that, let us just begin solving. Now I think we have to start with the minimum first. The 3 clue is the very obvious solution, because 3, there are a few ways to make 3, but you can only make it with either 1 digit or 2 digits. If it's with 2 digits, you make it with 1 and 2. If it's 1 digit, then it's just a 3. However, that obviously doesn't work, because if it's just 1 digit, which is a 3, you will imply that all 3 of those digits have to sum to 3, which isn't possible. Which means this has to be a 1 and a 2. And we can actually do better. If this is a 1, that wouldn't work, because it's only taking that 1 digit itself, which is a 1, and not 3. So it can't be that, it must be 2 with a 1, and this works out to make 3, because the first 2 digits do sum to 3. So it's kind of restrained, but not exactly restrained. It's a bit hard to figure out, but smaller clues actually give you a lot of information. We can actually do the same with the 5 here as well. Yes, alright. And I didn't really elaborate, but you also can't make 3 digits sum to 3 because all of them have to be 1, which clearly doesn't work. Alright. Next up we have 5. Well, 5 is kind of similar in the fact that it's either 1 digit or 2 digits, because the minimum for 3 digits is actually 1, 2, and 3, which is a 6. So this could be 1, 2, and 3, but this one cannot be 1, 2, and 3. And so this is either 1 digit or 2 digits. If it was 1 digit, similarly it wouldn't work. Well, because of the 5 here firstly, but also because you would then imply that all 5 of those digits sum to 5, which doesn't work. So it's 2 digits sum to 5. It's either 1, 4 or 2, 3. Now we can remove 1, 4 as an option, because if 1, 4 was the way to get 5, then the 1 has to be here, which indicates that this is the only digit which adds up to 5, which it doesn't. So it can't be 1, 4. It must therefore be 2, 3. This 2 resolves that for us. This also works because the 2 here implies that those digits sum to 5, which they do. Okay. Sorry, oh jeez, I had to sneeze there. Alright, maybe the 6 clues next. I was saying the 6 clue does have a few options though. Obviously, once again, it cannot be a single digit sum to 6. It could be 2 digits though if you had 2, 4. It could also be 3 digits if you had 3, 1, 2. That's also a valid way of writing your 6. So now we're starting to have options here. So I'm wondering what we should do. Maybe we should do like actual Sudoku, right? No? No, okay, never mind. What's another good number to look at? Say the 9 maybe, because that digit should be quite large. Well, it is at least a 4, because it can't be 1, 2, or 3. But whatever that digit is, doesn't affect this digit. Although to be fair, this digit should be quite small as well. In fact, it has at most a 3. Right. And that is because 4 digits at minimum will be 1, 2, 3, and 4, which already sum to 10. So this is at most a 3, meaning it's either 1 or 3. That does help us because it cannot be 1. That would imply this digit itself would have to be 9, which it is not. So it can't be 1. It's not 2 either, so it's a 3. So these 3 digits sum to 9. those 2 digits sum to 6 for therefore. And therefore this digit, well, this digit will have to be smaller than 6 because those digits sum to 6. But this digit cannot be 1, 2, 3, or 5 by row and box. So that digit must just be a 4. That's the only digit you can place in there, meaning that digit will have to be a 2 to form a total sum of 9. Interesting. Okay. Now what? Should we do the same for the rest? This digit, for example, is at most... Well, it's not at most... Yeah, it's at most a 3 because 4 digits again is at least a 10. So that digit is at most a 3, meaning it's either 2 or 3. Can't be 1 because, again, 1 doesn't work. The 7 does the same thing. Where it is, again, at most a 3 but cannot be 1. So it's a 2 or 3. We can also do the same for the 10. The 10 must also be 2 or 3 here, which gives us a pair. And the reason why is even though theoretically 4 digits at minimum could sum to 10, that 7 over here is quite pesky and will give a sum of at least 7 plus 1, 2, and 3, which is 13. So if you took 4 or more, you'll be summing to at least 13 already, which doesn't work. So this at most, once again, sums 3 digits, which means that this digit is at most 2 or 3, at most a 3. But can't be 1 for the same reasons. Can we figure out... I mean, I can figure out options for that digit. If this is a 2, then this must be a 4 to make 6. If it was a 3, then you would need 1, 2, and 3. That digit can't be 2 or 3, so it have to be 1. Meaning this is a 1 or a 4. Not entirely sure how that would help us though. So, never mind. I mean, this is also similar. Oh, this is also similar. Yeah, this 8 does the same thing as this 9 over here. Because once again, this 8 at most sums 3 digits. So that digit has to be either 2 or 3. Sorry. But because this digit is already there, this must be just a 3. Those digits therefore sum to 5, but cannot use 2, 3 because 3 already exists in the row. So it must be 1, 4. That is resolvable by the 1 up here. So I was actually pretty close when I gave my example of 3, 1, 4. It's 3, 4, 1. Okay. Now what about this? I mean, that digit is pretty interesting. That digit is actually at least a 4. Right? Because it can't be 1, 2, 3, or 5. It's at least a 4. Can it be 6? Well, it cannot, because 6 digit at the very least would sum 1, 2, 3, 4, 5, and 6. And those 6 digit would at minimum sum to 21, which is already way bigger than 13, sorry. So this digit is actually just a 4, because that is the smallest it can be, and also the largest it can be. And now what we're saying is that those digits sum to 13. Now, because those digits sum to 5, those digits therefore have to sum to 8 for 13 to work. And for 8, you cannot use 1, 7, or 2, 6 anymore. And therefore the only thing you can use is 3 and 5. That 3 resolve that for us. So there you go. What about those digits? That forms a triple consisting of 6, 7, and 8. Which do not interact with any X sum clues in any way. So we will not look at them yet. Okay, now what? I mean, there's still other clues we haven't looked at, but those clues actually could in fact be... Oh, this can't be 4 digits. This has to be 3. So this is either 2 or 3 once again. And the way I prove that, well, do I want to prove that? The way I prove that is by saying that if this was 4 digits, what does it have to be? 11 in 4 digits has to be exactly 1, 2, 3, and 5. And the reason why is because if you took the minimum, you would get 1, 2, 3, and 4. To get to 11, you would need to increase one of these digits by 1, but cannot repeat because they're all occupying the same column. And to do that, you can't increase 1, 2, and 3 because those will give you repeated digits. But you could increase 4 by 1 to give you 5. And 1, 2, 3, and 5 do in fact sum to 11. And this is the only way to have 4 digits sum to 11. However, in this case, that is not possible here because 5 already exists in the column. So it cannot be that 4 digits sum to 11, it must be 3 or less. So once again, this digit is at most a 3, but can't be a 1. So again, we have another pair over here. I mean, this not the same. This could be 1, 2, 3, 6. Yeah, it could be a lot of things. Oh, I mean, it can't be 1, 2, 3, 6 because they would have a 4 in it, but you get what I mean. We have a lot more options there. Really? I don't actually see what we have here. Like we have surprisingly little to go off of. After this point, we've basically used almost every viable. Or have we? This can't be a 3, can it? Because if it was a 3, how would you have 7 in 3 cells? The only way is 1, 2, and 4, by the same principle of minimum we can have in 3 digits is 1, 2, 3. We need to increase one of them by 1 to make a 7, because it's on the 6 currently. And the only way we can do that is to do this. Change a 3 into a 4. So the 1 to 4 is the only way to get 7 in 3 digits. However, if there were 3 digits something to 7, that would imply this digit is a 3. But that contradicts itself, because the 3 digits sum to 7 do not include a 3 in it. And in fact include a 4 and a 1, which isn't possible at all at this point. So in fact this digit cannot be a 3, it must be a 2. And therefore that digit will have to be a 5 to sum to 7. Cool. Now that gives us a 3 over here, meaning these digits sum to 11. This 3 here means those digits sum to 8. And while we cannot use 3, 5, but we could use 1, 7 or 2, 6. Both are valid. So again, not helpful. We can do regular Sudoku though. Place a 3 in this box. The 3's here. Help to place 3 in this cell over here. Which removes... that resolves this. That's a 2. Meaning that's a 3. Therefore that's an 8 to make 10. And we know because these must sum to 6. The only way we can do that is with 1, 2, and 3. This must be a 1. That must be a 2. Nice. Making progress. 3 in this box we can place here because of the 3's around it. And does it give us all the 3's? Almost. The 3 in this box we can also place right there. So those last 3 digits in the box have to be 6, 7, and 8. Oh, and that is useful because the 7 and 8 here gives us a 6 right there. Okay, awesome. What else do we have? Well, I think we're done with most of the clues. The 12 is the last one we haven't used yet. So I wonder how we will resolve that. This clearly can't be a 1, but yes, it must be a maximum of 4, which it has to be, I think. Because it can't be 5. If it was as large as a 5, then that would at minimum already sum to 15, which is way bigger than 12. So this can't be as large as 5. It can't be a 2 or a 3, and it can't be a 1 either. So it must just be a 4, meaning those digits sum to 12. Because that sums to 6, that must also sum to 6. And the only way we can do that without using 2, 4 is using 1, 5. This one will resolve that for us. So there you go. Awesome, and I think we're done with all the clues. No we haven't. That has sum to 11 yet, but I think that one is pretty easy to memorize. Alright. Let's do regular Sudoku now. This has to be 4 and 5. That resolves. This forms a triple consisting of 7, 8, 2? 2, 7, 8? Yeah, and that digit can't be a 2. So 2 goes here. And that forms a 6, 7, 8 triple. Well, actually we don't really need that. We have a triple right here, which should give us another triple over here. So what is this? Is it 6, 7, 8 again? Yes, it is. Okay. And then those digits would have to be 1, 4, and 9. Meaning that this can't be a 1, that can't be a 4. Doesn't help us. Alright, cool. Probably just a lot more Sudoku in the way. Yeah, like that's a triple, in fact. So that's kind of neat. This has to be, I think, 6, 8, 9, sorry. And that digit cannot be 9. Oh, I think we can place a 4, 5 pair in here. Because of the 4s and 5s, they can't be in those cells. And they can't be anywhere else in there. So 4 and 5 has to appear in here. Those digits are therefore 1 and 7 to finish the box. This one resolves that. This therefore forms a 6, 7, 8 pair, I think. Triple, sorry. 6, 7, 8 triple. This also forms a 6, 8, 9 quadruple. Triple as well. Why do I keep saying that? It's just a triple. Just a simple triple. Okay. Oh, there's another triple over here. This has to be, I think, 6, 8, 9 as well. And that digit cannot be 8. Cool. Have we figured this out yet? No, it could still be 1-7 or 2-6, right? Dang, that's a shame. That was unlucky. I think we just do regular Sudoku. Like 4 and 9. Yeah, in this box, 4 has to go in one of those cells, 9 has to go in one of those cells. So that forms a 4-9 pair. Which means this is another pair, which has to be, I think, 5 and 6. Yeah. Alright, that forms another pair here. I think we're getting pairs all the time now. I think this has to be 2-8. Oh, and we can resolve that. So this is 8, that's 2. This has to be a 1 and 1-6. Sorry, 1-6, yes. Alright. Still not a lot to go off of, but we can cope, I think. Like 2 in this box? Yeah, 2 in this box has to be here. Which does what? I don't know what it does. Oh, it gives us this thing. This sums to 11. So that has to be a 6 to make 11. That gives us no 6 over here. That also resolves this 1-6 pair. That digit has to be an 8, therefore. Which means what? Which means 1. Oh, that digit is just a free digit. That's just a 7. So that gives us a 6 here, 9 there. Nice. That means that's a 1. That can't be 7, so that's an 8. 7 must go up here. So that must be a 6. 7, 8 here is resolved as a result. The other way around. What does that do for us? That resolves this, I think. This 9 resolves this. So that's a 6, that's an 8, that's a 9. We're pretty much done. Just gotta do a lot more Sudoku. This has to be 1 and 9. So that goes 9 there, 1 here. 9 gives us a 4 here. This 1 resolves the remaining 1-9 pair. That gives us a 6 right here. That can't be a 9. So 9 goes down there, which means this is an 8. 6 resolves this 5-6, which moves ahead to resolve this 4-5, which then resolves this 4-9. Awesome. 6-8 means that's a 7, so 8 goes down here, 6 goes down there. That has to be 4-7-8. So that's 8, that's 7, that's 4. Nice, solved the puzzle in 16 minutes and 17 seconds. Okay, I don't have a lot of experience with XSum, so it did take me a while to realize how each of these will be resolved. But I think XSums are quite cool. Like, it's a very unique little experience. Like, wow. Yeah, I find it interesting that even these numbers alone can give you enough information. They're restricted enough to give you enough information. You know, but they kind of feel very esoteric in that sense. It's not like your regular thermals and arrows and killers, which appear basically everywhere. Yeah, it's special. So yeah, quite enjoy it. Alright, so hope you enjoyed the video. I'll see you guys next time. Bye bye.